This file contains a polarization converter which converts between the fundamental TM mode of the narrow waveguide and the first order TE mode of the wider waveguide. We'll add ports across the input and output waveguides to extract the S parameters of this device. Add 2 ports by clicking on the port button in the main toolbar twice. Expand the FDTD simulation region object and ports group to see the port objects in the object tree. By default, the geometry of the ports matches the simulation region span. Select and edit the ports group. This is where you can specify the source port and mode, and the number of frequency points for the internal frequency monitor to record over the wavelength range. The ports will inject light over the wavelength range specified in the global source settings. To modify this, click on the Set Global Source Settings button. Set the wavelength to 1.5 micron and the wavelength span to 0. Click OK to accept the global source settings and the port group settings. Next, edit port 1 and set the X position of the port to -2.6 microns so it's located at the wide waveguide cross-section. Under the Modal Properties tab, set the mode selection to User Select and click the Select Modes button. Click Calculate Modes and select the second and third mode from the mode list, which correspond to the first order TE mode and fundamental TM mode, by pressing the Control keyboard button to select additional modes. Click Select Modes and then click OK to accept the port settings. Next, edit port 2 and set the X position to 2.6 microns to place the port over the narrow waveguide cross-section. Under the Modal Properties tab, set the direction to backward. This will mean that the input direction of the port is in the negative X direction, and this affects the direction which is considered to be the input and output directions when the S parameters are calculated. Finally, select the first order TE mode and fundamental TM mode for this port the same way as for port 1. Next, edit the ports group and check what port and mode will be used as the source. Select port 1 mode 2 to use as the source, which corresponds to injecting the first order TE mode from the wide waveguide on the left. In the CAD view, you can see that the light will be injected from port 1 since it has a pink arrow. Port 2 will not inject and will only act as a monitor. Run the simulation. After it completes, you can click on the port objects and check the Result View window to see the list of available results. With port 2 selected, right-click and visualize the S result. Apply the absolute value squared scalar operation to get the absolute value squared of the S parameter. We can see that less than 20% of the light gets output through mode 2 of port 2, and about 80% is output through mode 3 of port 2. From the port monitor results, right-click on E to plot the electric field profile over the port, and right-click on T to plot the total transmission. To get the full S matrix, it's possible to use the S parameter sweep tool. Open the Optimizations and Sweeps window and add an S parameter sweep task. Edit the sweep where you will see that it's automatically set up to sweep all ports and all selected modes. Click OK, then run the sweep. This will automatically sweep through each port and mode combination to use as the source, and collect the S results from each file. After the sweep is completed, right-click on the sweep and plot the S matrix. You can view the matrix by double-clicking on the View Data button. You can also right-click to export the S parameters to Interconnect, which is Lumerical's photonic integrated circuit simulator. For more details about the S parameter sweep tool, see the related links below. Now let's go over some points to keep in mind for using ports. Ports must be added after adding the simulation region, since they are a child of the simulation region. The port group contains all of the ports and sets the port and mode which will be injected. Only one mode can be injected at a time. Using ports in conjunction with the S-parameters sweep tool allows you to extract the S-parameters of a device. Because port objects act as both monitors and sources, this reduces complexity in the setup. And because they return S-parameters based on the specified input direction, it also removes the need for any additional post-processing of monitor data to calculate the S-parameters.